స్టార్ట్ చేశారా? టైం ఎందుకు పడుతుందా? టైం ఎందుకు పడుతుంది? స్టార్ట్ చేయండి అంటున్నా. చెప్పు, స్టార్ట్ అయినా చెప్పు నాకు. గుడ్ ఈవినింగ్ ఫ్రెండ్స్, వెరీ గుడ్ ఈవినింగ్. Hope you are all preparing well for coming GATE exam 2022. Here, it is an initiative from the GATE ESE about this GATE throw questions. In this GATE throw questions, basically, we want to discuss as faculty, we want to discuss the expected questions coming 2022 GATE exam. Hopefully the exam date it is a known. On 5th February we are having exam. So here basically in this GATE throw questions GTQ, we want to discuss the expected questions in the GATE 2022 exam. It is the intention. Here myself, I am Srinivas. I will be discussing the digital logic expected questions in the coming GATE exam. The digital logic syllabus, basically we are having 4 major topics. One is the basics, the Boolean Algebra, next number system, combinational circuits, and sequential circuits. So while looking to the last 5 years question papers, here I am going to discuss the expected questions in the GATE exam. Let me start the session with the Boolean algebra questions. The question we are having here, the first question is, for the given Boolean function, identify false statement or statements. So we are having statement A, number of prime implicants always greater than the number of essential prime implicants. The option B, we are looking, if the function is having cyclic prime implicant K map, then the minimal forms are equal to 2. The minimal forms are 2. Option C, we are looking, if the function is having unique minimal form, then the products which are present in the minimal expression all are essential prime implicants. The option D, if the number of prime implicants are k and number of essential prime implicants are k minus 1, then the function is having unique minimal form. So these are the ABCD options. It is a question I given as a multi-select question, MSQ question. They are having a possibility more than one option may be coming as the answer. This question is concerned, we need to identify the false statement. This question is concerned, we must identify which is or which are the false statements. So just take some time and try to respond, try to answer. So let me check your answers. Don't take much time. So here I am looking some answers from your side. So let me speak which are coming to be the false statements. Here I given a question in such a way that it is going to cover all about the K-maps related with the prime implicants and essential prime implicants. So number of prime implicants always greater than the number of essential prime implicants. It is a statement, it is given. So if you look to the whether the statement is true or not. So this statement definitely we are looking as the false statement. Number of prime implicants we are talking here in the option A always greater than the number of essential prime implicants. It may not be the case always. Say for example, if we are having a function of 3 variables, I am having a function here of 3 variables. If I am having, these are the minterms for this function. If these are the minterms of this function, here we are looking to the number of prime implicants. I am not going in detail. For MADG students, it is well known. So what we are talking here, you can see function is having 4 minterms. Number of prime implicants are 2 and number of essential prime implicants also 2. Number of prime implicants are 2, number of essential prime implicants also 2. For non-MADG students, if at all you want, here we are taking the function with the minterms of 0, 1, 6 and 7. The minterms of this function we are looking as 0, 1, 6 and 7. For this function, if at all we are looking the number of prime implicants. The number of prime implicants we are looking while grouping all possible larger size subcubes. For this function, all possible larger size subcubes, if at all you are looking, we are having only 2 larger size subcubes. So answer to the number of prime implicants is 2. And coming to the number of essential prime implicants, number of essential prime implicants of the given function are equal to number of all possible larger size subcubes in which at least one cell without overlapping. At least one cell without overlapping. It happens so for this subcube, cell 0 and cell 1, no overlapping. Similarly, here also through cell 7 and cell 6, no overlapping. So both are coming to be essential prime implicants. So based on this here, the number of prime implicants are equal to the number of essential prime implicants. But the statement what we are having, option A statement में क्या दिया अपन, number of prime implicants always greater than the number of essential prime implicants. ये तो गलत statement है. So false statement है. And coming to option B, if the function is having cyclic prime implicant K-map, then the minimal forms are 2. Of course, this statement is coming to be true. As and when the function is having cyclic prime implicant K-map, the function is having exactly 2 minimal forms. And if the function is having unique minimal form, then the products which are present in the minimal expression all are essential prime implicants. And of course, the statement definitely is a false statement. It is a false statement. You can see here, option C is concerned. If you want to see an example, you can make an example. Suppose we are having a function on these 4 variables A, B, C, D. Suppose we are having a function with the minterms as, you can see here, the minterms we are having for this function are 1, 6, 7, 9, 9 and 13. So for this function, if at all we are looking, we are having this is essential prime implicant, this is essential prime implicant. So that whenever you are trying to read the minimal form, these subgroup products will present. There is one missing here. 15 also there. So we are looking here. These two are essential prime implicant. The subproducts corresponding to these two subgroups will be present in every minimal expression. And coming to this is not essential prime implicant. But whenever we are writing the minimal form, we are going to take the product corresponding to this. The product corresponding to this is not a essential prime implicant, but in the minimal expression it is going to present. I'm not going in detail the product forms because it is object type question, so we have to minimize, and within the available time of around 1.5 hour time, I want to cover whatever the best possible questions which are possible. So I'm not going into those details. So anyway, whenever you are whenever you are going to write the minimal form, these two subgroup products are present. They are essential prime implicants. The products corresponding to these are EPIs. This is also EPI, but this is not EPI, but in the minimal expression this is present. So question statement, what we are having the option C, if the function is having unique minimal form, then the products which are present in the minimal expression all are essential prime implicants. So it's a false. This is not a essential prime implicant, it is a false. And coming to this, very good statement this also. If the number of prime implicants are k and number of essential prime implicants are k minus 1, then the function is having unique minimal form. Then the function is having unique minimal form. So if you want to look to an example for this, इसके लिए example देखना चाहे तो, suppose consider we are having a 3-variable Boolean function. A 3-variable Boolean function, let us consider. These are the minterms. So function we took with the minterms of, this is 0, this is 1, this is 5, this is 7. So minterms we are having 0, 1, 5 and 7. Okay, and if you look here, this is EPI. The product corresponding to this is EPI. A subgroup ka product be EPI, right? And we are having, this is also a prime implicant. But of course, this is not a EPI, it is not a EPI. So number of prime implicants on this, is 3. Number of essential prime implicants, EPIs, we are having as 2. So the statement what we are having is, number of prime implicants are k, number of essential prime implicants are k minus 1. Then the function is having unique minimal form. Of course, in this case, we are having the group of these two subgroup products, essential prime implicant products, we are having the expression. It is going to be only one minimal expression. So what we are looking is, if the number of prime implicants are k and the number of essential prime implicants are k minus 1, then the function is having unique minimal form. This statement is coming to be true. This statement is coming to be true. We need to identify which are the false statements. So based on this, the answer for this question, is option A and option C. I am looking, few of you given the right answer, and if you look to the notes, MEDIS students, if at all, majority of you may be MEDIS students, if you look to the notes, the similar type of questions, we are having many questions which are covered with different examples. Just to revise all those things, here I given this question. So it is looking to be a theoretical question, statement based question, but to answer this statement based question, you need to know the knowledge of the K-map, how to identify the prime implicants, how to identify essential prime implicants when we are naming the function as cyclic prime implicant K-map. And with the knowledge of all these, the statements what we mentioned, we are able to identify which is correct statement, which is not correct statement. So based on this knowledge on this question, whenever we are looking to the false statements, we are having the answer is option A and option C. Both are false statements. Let us move to the next question. This question is based on the number system. This question is based on the number system. When 2's complement of binary number B is added to 2's complement of binary number A, if result is without overflow, if the result is without overflow, this implies the result is. It is also a MSQ question. Option A, I given negative and is in the normal form. Option B, negative and is in 2's complement form. Option C, positive and is in normal form. Option D, positive and is in 2's complement form. So here, this normal word what we are looking, basically referring to true magnitude. So negative and the magnitude is true magnitude, normal means. Whenever we are having a normal, the meaning is magnitude is true magnitude. So try to answer to this question. So I'm looking correct answers from few of you. Very good. Everybody can try. The answers we are having here, this option B and option C. So question, if at all you are reading well, in the exam, reading question very well is very much important. You have to understand basically each and every word of the question. Once you are understanding each and every word of the question, you can give the correct answers without any difficulty. When 2's complement of binary number B is added to 2's complement of binary number A, if result is without overflow. So let us try to underline this wording. So whenever 2's complement of binary number B is added to 2's complement of binary number A, if the result is without overflow, this implies the result is, it is a question. So let us make an example to identify the answer A and B in such a way, whenever 2's complement of B we are adding to A, there should not be overflow. So we have to develop an example so that whenever we are adding the 2's complement of the binary number B to A, we don't want to read the overflow. So with that condition, it is possible to recognize how option B and option C are coming to be the correct answers. So let me take some sample. Suppose I am having binary number A is say plus 3. Binary number B is plus 2. Whenever I am adding these two, the result is this. So plus 3, the 2's complement form is 0, 0, 1, 1. Plus 2 in the 2's complement form 0, 0, 1, 0. So whenever the number is positive number, we know sign bit is 0 and in the 2's complement the magnitude is true magnitude itself. So when we are adding this, it is 1, it is 0, it is 1, it is 0. So we are looking here, there is no overflow, Okay, so result is positive and the magnitude what we are looking is true magnitude. It is a true magnitude. So option B is coming to be true. there is no overflow, so the result is positive and it is in the normal form. The result is positive and it is in normal form. Similarly, you have to make an example for this. So you have to make an example even for B. Suppose A consider as minus 5, B consider as plus 2. So when we are adding these two numbers, it is minus 3. So once it is a minus 5, so we are starting to read the 2's complement. We are starting with plus 5, and to read the minus 5 in 2's complement form, well, having the 2's complement operation on this. So we are moving right to left. Unless we are not reading the first bit is 1, we are reading as it is. Later we are having the bitwise complement. So that it is basically 2's complement for this representing minus 5. So that it is 1 0 1 1. And plus 2 we are having as 0 0 1 0. When we are adding these two, 2's complement of the binary number B is added to A. Whenever it is a positive number, no need to perform any complement. Whenever number is a positive, the 2's complement or 1's complement, it is as similar to as sign magnitude case. So I am trying to make the revise the number system what you learned. So when we are adding this, it is 1, it is 0, it is 1, it is 0. So that we are having a situation here, it is without overflow. We are having here the result is without overflow. So there is no overflow. And if you look here, the expected magnitude is 3 and number is negative number. And we are looking here, sign bit is, the sign bit is 1, the number is negative. And to read the true magnitude, it required to perform the 2's complement operation on this. So whenever you are having the 2's complement operation here, it is 1 1 0 0. So it is referring to the magnitude of 3. So that it is a minus 3. So what is given? The result is negative and it is in 2's complement form. So that what we are looking is, whenever 2's complement of the binary number B we are adding to A, if the result is without overflow, the possibility we are having, the number is positive and the magnitude is true magnitude. Other possibility we are having, the result is negative and the magnitude is in 2's complement form. So answer to this question is option B and option C. Let's move to the next question. The given number A 11011 and B is 00101. They are in 2's complement and 1's complement form respectively. This binary number A and binary number B are 2's complement and 1's complement form respectively. A and B are added. The result in hexadecimal form is, it is a question. So अपने पास binary number A 2's complement में है, binary number B 1's complement में है. दोनों नंबर ऐड करने के बाद जो रिजल्ट मिलेगा वो रिजल्ट अपने को हेक्साडेसिमल में होना. सो व्हाट इज द आंसर? Try to respond. You'll be giving correct answers. Try well. are having A, it is 1 1 0 1 1, right? So we are having it is in 2's complement and B is 1's complement. B is 0 0 1 0 1. So once we are having a description of the question, it is in 2's complement form or in 1's complement form. Default in the class many times I mentioned, it is an indication default sign 2's complement form or sign 1's complement form. In this case, sign 2's complement and sign 1's complement form respectively for number A and B. For this number A, we are having sign bit is 1. Once the sign bit is 1, the number is negative. The number is negative. And the magnitude is in 2's complement form. The magnitude is in 2's complement form. So to read the magnitude, it required to perform the 2's complement operation on this number. Whenever we are performing the 2's complement operation on this number, we are moving right to left. We are reading the bit as it is until we are not reading first bit is a 1. It is the first bit is a 1. Later we are having bitwise complement. So which is giving the magnitude as -5. Coming to binary number B, it is 1's complement form. Default here also it is sign 1's complement only. We are having sign bit is 0 so that the number is a positive. Once the number is a positive, the remaining bits are directly referring to true magnitude. The remaining bits are referring directly to true magnitude. So the magnitude part we are having here, which is 5. So when these two numbers are added, the result in the decimal form, of course, 0. In the hexadecimal form, if at all we are looking, here it required for us to write as 0 0 because we are having 5-bit case. Because of the 5-bit case, when we are giving the answer on this question, we have to write it is 0 0. So answer is 0 0. Just check yourself how many of you are able to give correct answers and how much time you are taking to respond. Let's move to the next question. Here I given very simple question. Let me look the right answer from everybody. I want to see the right answer from everybody. Very good. Many of you given right answer. Of course, it is little simple, straightforward question. We are having here the question is the base of the number system for the addition operation 26 plus 34 equal to 63. So basically we don't know what is the radix, what is the base of these numbers. So question is asking us to identify a question में अपने को a radix value b को identify करना. So assuming the radix is b, we are able to read here it is 2b plus 6 plus 3b plus 4 is equal to 6b plus 3. So which is giving 5b plus 10 is left side, right side 6b plus 3. So which is giving b as equal to 7. Hence answer we are having for this question is 7. You can have sometimes very simple questions also in the GATE paper. Every question may not be so complicated. Every question may not be related to the previous example 4 or previous example 3. You may be having sometimes very simple questions in something like this also. Let's move to the next question. F of ABC is equal to AB, it is exclusive OR operation. AB exclusive or BC, exclusive or AC, exclusive OR, this is also XOR, exclusive OR A complement C is equivalent to, it is equivalent to. This is also given as a MSQ question. So from the given options of A, B, C, D, we must identify which is coming to be or which are coming to be correct, which is or which are, because once it is MSQ, they are having a possibility only one of the option may be true, or maybe more than one options may be true, or maybe all the options may be true. So to work out on this question, you need to know few of the results what we discuss on the exclusive OR operation. While having the knowledge of the results what we discuss on the exclusive OR operation, the class, we are having possibility to work out on this question with less time. Recent times there was no question related with the exclusive OR. The last question in the previous GATE exam, if at all you're looking, it was probably what I remember well, 2019, it was the last question. So this time you may expect definitely a question related with the exclusive OR operation. A Boolean function or Boolean expression question may be आपको मिलेगा ये बार एक question paper में 2022 में, which may be related with this exclusive OR operation. Mostly, I'm guessing it is maybe present this time, this type of related exclusive OR related question in the GATE paper 22 में मिलेगा आपको. So try to respond. I'm looking, few of you are giving right answers, very good. The answer will be having B and D as correct. The given function is on these three variables. The expression we are having AB exclusive OR with BC, exclusive OR with AC, exclusive OR with A complement C. A है given expression. Among these two, we are having B is common. Once B is common, we are having possibility to write this as B A exclusive or C exclusive or A. लास्ट टू टर्म्स में C कॉमन है, लास्ट टू टर्म्स में C कॉमन है. सो C कॉमन लेने के बाद we are having possibility to write A exclusive or with A bar, A exclusive or with A bar. So this type of results we are having we had a discussion in the class, even while working with the workbook questions also. So you know well, from your notes you can see this is giving the result as 1. It is giving the result as 1, right? Just what we are doing is, here C is a common, so A exclusive or A bar, A exclusive or A bar result supposed to be known to you, it is 1. So based on this, in fact, just for convenient, we are taking here C common with reference to that I given, but here no need to take this. This I can write here as it is better. But to give the principle what you discuss in the class, for that I given. So here first two terms as it is. Now this is coming to be C. Once it is coming to be C, here we are having C as a common. So once C is a common, we are having here B exclusive or with 1, B exclusive or with 1. So this AB exclusive or as it is. This is also known to you. These are the things what you discuss in the class. It is B complement. So this is CB complement. This is AB, right? Now let us apply the normal exclusive OR operation. So whenever we are having XOR between X and Y, you know we are having the usage of this. So this formula we are trying to use. This you can speak for your convenient as X. For your convenient you can speak it is X, this as a Y, and you can go for normal expansion work. So if you do that, this is AB complement and with CB complement. CB complement or with AB, CB complement, complement. So here we are looking A complement or B complement and with CB complement or with AB. Here it is C complement or B by using De Morgan's property. So if you look here, it is giving A complement, C, B complement. Next one is C, B complement. AB, C complement, BB complement is 0. Check once, something going wrong it seems. think this I given wrong. This went wrong from my side. So this is A complement, B complement, C. So ABC complement, this is AB. So this is giving AB, right? And coming to this, this group is giving just B complement C. This is giving B complement C, right? So you can see now, so once I am having AB, it is a group of min-terms 6 and 7. Once I am having AB, the meaning is A is 1, B is 1, whereas C may be 0, C may be 1. So based on this, you are looking, it is a min-term 6, it is a min-term 7. Similar work, if we extend here, it is coming to be the group of min-terms 1 and 5. So that effectively the min-terms we are having as 1, 5, 6 and 7. The min-terms we are having as 1, 5, 6 and 7. So option B is coming to be true. And coming to the other one, if you come to this, effectively we are having here this expression is AB R with B complement C. So if you are remembering consensus property well, you can read this as AB on B के ऊपर complement है, C अलग है. So B complement C, AC ऐसा लिख सकते. If you are remembering the consensus property well, you can write this as AB, B complement C. Third term is coming to be AC. So variable B के ऊपर इधर complement second term में. So second literal इधर A है, इधर C है. So third product will be AC. By using consensus property, you can recognize this. It is one way. So anyway, if at all you are recognizing that it is coming to be AC, B complement C, AB. So option D is coming to be true. If at all if you are unable to get an idea about this, if you are not getting idea about this, then we are having always the possibility to use the K-map. So if at all you are using the K-map, you can able to recognize the products. So we are having here the function on these variables ABC. It is A, it is B, it is C. So we are having a product is A, B. Once I am having a product is AB, it is, these are the min-terms. So it is a min-term 6, it is a min-term 7. Other product we are having B complement C. So that this, so it is a min-term 1, it is a min-term 5. So as you know well, so 0, 1, 2, 3. By this time you might be had very good practice with K-map. Hence, identifying the cell numbers is not a difficult. This is one group, this is another group. This group is giving basically AB. This group is giving basically B complement C. And we are having here this. We are having here this subgroup. This is basically AC. So we are having possibility to write the expression as AB, B complement C, and AC we can use. Of course, it is not a essential prime implicant. The product is not a essential prime implicant. So to confuse the student, or the student, those who are having very good practice, to give the benefit to them, instead of giving answer directly as AB or with the B complement C, the option may be given by the paper setter like this. If the option is given like this, most probably you will be giving answer for option B, but you may not be able to give the answer to the option D. As a MSQ question, if at all you are giving answer for B as well as D, both are correct. Unless you are not giving both are the right answers, you are not going to get the marks. We are not having any partial marks on the MSQ questions. So to filter the students, sometimes the paper setter, instead of giving AB or with B complement C, he may be giving along with this AC, so that the students those are not practiced well or maybe possible jaldi mein miss hone ke chance bhi rehte. So anyway, the answer to this question we are having as B and D. Let's move to the next question. It is also MSQ question. It is also MSQ question. We are having here the question, read well. Function f is defined as exclusive NOR between f1 and f2. Function f is defined XNOR between f1 and f2 or with f3. f1 का मिनटर्म्स, f2 का मिनटर्म्स, f3 का मिनटर्म्स क्वेश्चन डाटा में दिया. You need to identify what is the function f. It is MSQ. Again, we are having a possibility more than one options may be coming to be true. So just take 1 or 2 minutes time and try. When you are responding to the answer, better write question number. Selectively, I am discussing very few questions, or mostly they are expected questions. And questions are framed in such a way that while trying these questions, will be having coverage of many different topics of the concerned different topics. Will be having the revision for many different topics while working a single question. So we are having here the function f1 is minterms 1, 4, 5 and 7. Function f2 का minterms है 2, 4, 6 and 7. Right? We are having here a function which is required to identify f1 XNOR with f2 or with f3. Right? And of course, all these functions on 3 variables. Let me look first f1 XNOR with f2. So when you are trying to read f1 XNOR with f2, आपको तो XNOR truth table का याद में होना चाहिए. Definitely everybody knows this well. ये तो दिक्कत बिल्कुल नहीं है. So XNOR truth table में you know well, whenever we are having both are zeros, both are ones, we are having XNOR result is 1. अदर टू केसेस में एक्स नॉर रिजल्ट इज 0. इट इज, तो आपको तो मालूम है, राइट. सो इसके हिसाब से इधर देखे तो वी आर हैविंग हियर कॉम्बिनेशन 4 इज अ मिनटम हियर. इन F2 में भी मिनटम है. इसका मीनिंग क्या है? जस्ट फॉर लिटिल क्लैरिटी आई एम गिविंग लिटिल मोर डिटेल्स. अगर आप 3 वेरिएबल फंक्शन डाला इधर, ट्रूथ टेबल, if at all you are giving truth table of this 3 variable, you are having, these are the combinations on these 3 variables. राइट. अगर आप F1 देखो, F1 का मिनटम्स क्या है? दिस इज, इट इज दिस द मिनटम्स फॉर F1. सो बाकी जगह क्या है? 0. राइट. F2 का मिनटम्स क्या है? F2 का मिनटम्स है 1 2 4 6 7. So 2 4 6 7, right? And other places you are having 0. Other places you are having 0. So this is F1 F2, right? We are having now XNOR between F1 and F2. So 0 0 रहे तो क्या होना? 1 होना. 1 0 रहे तो 0 होना. 0 1 रहे तो 0 होना. 0 0 रहे तो 1 होना. 1 1 रहे तो 1 होना. 0 इधर 0 इधर 1. So one of the example what I said 4. अगर 4 के देखे तो F1 में 1 है, F2 में भी 1 है. So that 4 will be there as a minterm. The same thing holds good even for 7 बोथ जगह है 1 1. So 7 will be there. इसके अलावा अगर कॉम्बिनेशन 0 देखे तो F1 में फंक्शन आउटपुट 0 है, F2 में भी फंक्शन आउटपुट 0 है. So that whenever 0 0 XNOR result is 1, right? Similarly कॉम्बिनेशन 3 देखो, इधर 0 F1 में, F2 में भी फंक्शन आउटपुट 0, दोनों 0 है तो 1. So instead of looking to this, you need to have a practice looking from here itself. 0 इधर भी नहीं है, इधर भी नहीं है, so that 0 guarantee it is the minterm, right? 1 देखो, 1 इधर minterm इधर maximum, so तो 1 तो नहीं मिलेगा, 1 तो नहीं मिलेगा. इधर एक minterm इधर maximum बोले तो नहीं मिलेगा. 2 same thing. 3 देखो, 3 नहीं है, इधर भी नहीं है, इधर भी नहीं है, means 3 both the जगह, both the places maximum means function output is 0. Then come to 4. Of course we already mentioned. 5, it is not with the output of 1 because it's the minterm, either maximum. 6 भी नहीं है, 7 भी नहीं है. So on the whole, the minterms, if at all you are looking, these are the minterms now. These are the minterms of F1 XNOR with F2. Hence, minterms we are looking as 0, 3, 4 and 7, right? And F3 तो directly मिला आपको 2, 3, 6, 7. The F3 का minterms है 2, 3, 6, 7. So on the whole, if you look here, the minterms we are looking as 0, 2, 3, 4, 6 and 7. So 0, 2, 3, 4, 6, 7. So one of the option is directly we are able to recognize option B. So option B is coming to be true, but A is wrong. Coming to this, here we are having simplified forms. Once we are looking to simplified form, it required first to use the K-map for reading the minimal expression. So function we are looking here, on 3 variables. So A, B, C, right? So if you look here, the min terms we are having as 0, 2, 3, 4, 6, 7. So hopefully you are having reasonable practice with these K-maps, so that no need to write the cell numbers. Hopefully I am looking in that way. So we are looking here. This is one 4-cell subcube. It is B, and we are having here this is another 4-cell subcube. It is giving C bar. So the function f will be B or with C complement. So one of the option here we are having. Hence answer to this question we are having as B and D. Very good. What I observed, many of you given right. Many of you given right for this question. So to work on this question, you need to know the knowledge of XNOR, and you need to know how to read the minimal form using K-map. So while having the knowledge of these two concepts, you are able to identify the right answer. Here I given the question as MSQ, but may not be MSQ in the exam paper. It may be sometimes directly MCQ. Once is MCQ, by chance you are having the option B as the answer, then it is easy for us to work out. So no need to go to the K-map. Let us move to the next question. Look to the question well. The question is related with the logic gate delays. In the given logic circuit, gate G1 and G2 are having the propagation delay of 2 nanoseconds and 1 nanosecond respectively. For the given input A, the output Y is, for the given input A, the output Y is, it is the input A. So here in the एग्जाम पेपर में तो आपको ऑप्शंस मिलेगा, ऑप्शन ए, ऑप्शन बी, ऑप्शन सी, some waveforms you will be having. So from the available waveforms you have to identify which is coming to be the right answer. You will be identifying the right answer, of course, if at all you are developing the waveform to the overall circuit output. So it is expected from your side, just take 1 or 2 minutes time and you can try for the output waveform. It is not a complicated problem, it is little simple straightforward problem. More complicated problems in fact we discuss in the class. They are available in the workbook also. So comparing to those problems, it is a little simple problem only. So as a computer science students, generally you may not be having much complicated problems with the delay problem. Delay questions may not be so complicated to you. For EC students it may be, but not for you. So gate G1, of course, here I not mentioned, it is G2. So G1 is having the propagation delay, it is mentioned as 2 nanoseconds. G2 is having the propagation delay 1 nanosecond. It is the input A. So input A before 0 it is 0, at 0 it is getting some pulse signal, later from 1 to 5 it is 0, after 5 it is 1. You are looking here, it is XOR gate. XOR gate, one of the input is 1. Whenever one of the input is 1, XOR output, you know well, XOR output is complement of the input. So output supposed to be a complement, right? But here we are having a value addition. What is the complement output you are reading? That complement output is delayed by 2 nanoseconds. It is delayed by 2 nanoseconds from the gate G1 output. It is delayed by 2 nanoseconds from the gate G1 output. So if you look to the output of gate G1, we are looking to the output of the gate G1. So before 0, it is 0. Input is 0. So that before 0, we are having output of XOR is 1. So XOR is working as an inverter. At 0 nanosecond, the input is changing this 0 to 1. So whenever input is changing 0 to 1, the output of this XOR must be changing 1 to 0, must be changing 1 to 0. It's the inverter. But to change, it needs 2 nanoseconds time. So input is changing 0 to 1 at 0, so that we are having the effect of this when we are reading from this G1 output. We are having this effect only after 2 nanoseconds. Hence, we are having, what is the output we are having? That output is coming to be 0 after 2 nanoseconds. After 2 nanoseconds, it is coming to 0. Right? And at 1 nanosecond, it is falling to 0. It is falling to 0. So this effect we are reading from the output of this XOR after 2 nanoseconds. 1 plus 2. So after 3 nanoseconds. After 3 nanoseconds, it is 1. It is 1. You can go even a cross check something like this. For a duration of 1 nanosecond, it is 1. Hence, for this portion, if at all you are thinking our idea, we are limiting our idea. So for this 1 nanosecond, the gate G1 output must be 0. Of course, it happens so. It happens so. So for a cross check, you can think even like this. Later, at 5 nanosecond, it is getting 1. Means the effect we are reading after 2 nanoseconds. When it is applied 5 plus 2 means after 7 nanoseconds, we are reading it is coming to be 0. Right? Later, we are having, it is 1 means here we are having as 0. So you can think even here also a cross check something like this. 1, 2, 3, 4. For 4 nanoseconds, we are having input A is 0. For 4 nanosecond, input A is 0 means, if we are limiting our discussion only to this part, the gate G1 output will be 1 for this 4 nanoseconds. You can check, is it true or not? 1, 2, 3, 4. So for this 4 nanoseconds, we are having output of the gate G1 is 1. Of course, it is right. So this is output from the gate G1. And coming to the gate G2. G2, one of the input is 1. So once one of the input is 1, from the knowledge of AND gate, you know, whenever I am having one of the input is 1, if I am having other input is X, and output we are reading as same as the input X, but it is here delayed by 1 nanosecond. So little value addition we are having. So what is the waveform we are having here? The same waveform, wave shape is concerned same, but this is to be delayed by now 1 nanosecond. So if it is delayed by 1 nanosecond, we are looking to the waveform as like this. So default nanoseconds this is indicating here. Okay. It is Y, right? So it is delayed by 1 nanosecond. At 2 nanoseconds, false 0 means it is going to be false 0 at 3 nanoseconds. At 3 nanoseconds is getting means it is delayed by 1. At 4 nanoseconds is going to get 1. At 7 nanoseconds falling to 0 means at 8 nanoseconds falling to 0. Right? And later of course it is 0. You can check. So 1, 2, 3, 4. For this duration it is 1 as it is. So there is no any wave shape changes, there is no, but delayed by 1 nanosecond. Hence the answer to this question is this. This is the answer. So in the given ABCD options, you will be looking, one of the option is coming to be this. It is coming to be one of the option. Let us move to the next question. Read question well. It is easy question, good question also. You can expect this type of question this time in the GATE paper. This type of question was very long back, it was a question, very long back, it was a question. Recent times there was no question, recent time there was no question related with the binary adder also. So you can expect this time this type of question. So let me look quickly. We are having here the given logic circuit is having 4 binary number as the input. B3, B2, B1, B0 is the input, and D4, D3, D2, D1, D0 as the output. The circuit operates. Option A is given binary to gray code converter. Option B is given binary to radix 13 converter. Option C is given binary to radix 12 converter. Option D is mentioned none of the above. None of the above. For MADEC students, probably it is easy. You might identify by this time. We are having here, based on this addition operation, you may be recognizing at this place, we are having this 0, 0, 1, 1 addition. So we are having basically the addition of 3. When I am having addition of 3, it's supposed to be binary to radix 13 converter. It's supposed to be binary to radix 13 converter. As you know well, with the knowledge of BCD number corrections, we are looking here, there, in the case of the BCD correction, we are having add 6 operation. For BCD, we are having total number of input bits are 4, total 16 combinations. For BCD case, the usage is 0, 1 and so on 9. We are having the usage of these 10 combinations. 6 combinations are not used, so we are having here add 6. And here also we are having input data only with 4 bits. Total 16 combinations. We are having here addition of 3. So once we are having addition of 3, it is possible to recognize out of these total combinations, we are having the usage of 0 to 12. Whereas this combination 13, whereas the combination 13, 14 and 15 are not used by the circuit. It is the reason we are having here add 3 operation. In the case of this, we know the combinations corresponding to this 10, 11 and so on 15 are not used. So 6 combinations, so add 6 operation. We are having here add 16 operation, add 6 operation. Here add 3. So once it is a case, 0 to 13 means 0 to 12 means total 13 combinations. It is a radix 13 number basically. So with this idea, without any much work, with this idea, without doing any much work, you can pick this is coming to be the right answer. And if you want little more clarity on this question, if you are non-MEDIG student, you want more clarity on this, many of you may be MEDIG students, then you can take some sample number and you can try. Suppose I am having input binary number, this B3, B2, B1, B0 is I am having as 1111. It means it is referring to decimal 15, right? Once I am having decimal 15, we are having radix 13 equivalent we want to write. It's supposed to be this. Radix 13 equivalent we want to write for decimal 15, we are having, it's supposed to be this, right? So if at all we are having, this is the input to this circuit. I am having this 1111 is the input to this circuit, and based on this logic you can identify B3. When I am having this B3 and B2 are 1 then this OR gate output is 1. So once OR gate output is 1, I am having here for this it is 0 0 1 1. So I am having addition operation here inside. Once I am having addition operation, if you look to the result, this is giving 0, this is giving 1, this is giving 0, this is giving 0, it is giving 1. So we are able to recognize this is basically referring to this 2, 0 0 1 0, and this is this 1. So that we are having here the output is radix 13 equivalent. We are having the output is radix 13 equivalent. So like this, for other samples also you can verify. Whenever the input binary data is 0 to 12 corresponds, we are having this is coming to be 0. This is coming to be 0 corresponding to this. Whenever input binary data corresponding to this 13, 14 and 15, we'll be having output of this logic circuit is 1. Once output of this logic circuit is 1, we are having here add 3. I am mentioning once again, corresponding to this logic circuit output, we check with some other example, it is 1. Corresponding to this input logic circuit output is 0. So on the whole question is concerned, it is converting binary number to radix 13. So answer is option B. Let us move to the next question. A 4-bit right shift register is shifting the data to the right for every clock pulse. The serial input is derived by using XNOR gate as shown in the figure. The initial content in the register is 1010 at QA, QB, QC, QD. After how many number of clock pulses the circuit is back to the initial state? So this question I given as a numerical question. So a circuit है 4-bit right shift register. A 4-bit right shift register में initial content है 1010. After how many number of clock pulses it is back to the initial state? It is a question. So shift register question recent times we are not having in the GATE computer science paper. It is expected this time, this type of question, and mostly there will be a question definitely on the shift register. Last time there was a question and a counter, a simple question with 2 flip-flops in 2021 GATE. Since last 3-4 years there was no question from the register. So based on the statistics, I am expecting this time there will be a question on the shift register. Try to answer. So many of you are mentioning right answer. Many of you mentioned right answer. The answer is 6. QA, QB, QC, QD. We are having initial content in the register is 1010. Serial input is XNOR between QB and QD. It is the exclusive NOR between this QB and QD. Right? So क्लॉक देने के पहले serial input देखिए तो QB XNOR with QD is 0. As and when you are giving clock, this is sorry, this serial input is coming to QA. It is 0. This is 1. This is 0. This is 1. Right? So it is not initial content. So we need to go further clock pulses. So before next clock pulse, QB QD दोनों का value 1 है. XNOR operation की वजह से, I think I given wrong now. This is given wrong. So QB QC दोनों 0 0 है. XNOR बोले तो it is 1. Right? This is 1 then. Okay. So before next clock pulse we look QB QD दोनों 1 है. दोनों 1 होने की वजह से XNOR का result 1 मिलेगा. Second clock pulse डाले तो are having this. Right? Now QB is 1, QD is 0. एक 1, एक 0 बोले तो XNOR operation result will be 0. So when you are applying the third clock pulse, आप third clock pulse डाले तो इधर 0, इधर 1, इधर 1, इधर 1. So it is not initial state, we are going further. So before next clock pulse देखिए तो QB QD दोनों 1 है, so serial input 1 मिलेगा. Clock डाले तो this is 1, this is 0, this is 1, this is 1. Now next clock के पहले QB QD देखिए तो 0 1, so it is 0. Fifth clock pulse डालो, it is 0, it is 1, it is 0, it is 1. So it is not initial state, we are going further clock pulses. Next clock के पहले देखिए तो that is 6th clock pulse, next clock pulse. QB QD दोनों 1 है, so XNOR का result 1 मिलेगा. आप 6th clock pulse डाले तो 1 0 1 0. So it is back to the initial state. It is back to this initial state after 6 clock pulses. So answer to this question is 6. Based on this we are speaking, the answer to this question is 6. Right? The next question also related to the same. Referring to the same question 10. A 4-bit right shift register is shifting the data to the right for every clock pulse. The serial input is derived by using XNOR gates as shown in the figure. After 3 clock pulses, a question थोड़ा बराबर समझो. After 3 clock pulses, the content in the register is to be 0 1 1 0. At QA, QB, QC, QD, what will be the initial content of the register in decimal equivalent value? ये है क्वेश्चन. सो 3 क्लॉक पल्सेस बाद डालने के बाद आपका रजिस्टर कंटेंट वी वांट 0110, सेम फिगर. सो ए 0110 3rd क्लॉक के बाद में मिलना चाहे तो इनिशियल कंटेंट आपको क्या होना चाहिए रजिस्टर में, ये है क्वेश्चन. ए रजिस्टर का इनिशियल कंटेंट आपको क्या मिलना, ये है क्वेश्चन. सो वी नीड टू गो bottom up analysis. In this case we need to work for bottom up analysis, right? So just take few seconds time and try to respond. थर्ड क्लॉक के बाद आपको होना चाहिए 0110. We want 0110, right? What will be the initial content of the register? We know serial input is XNOR between QB and QD. We are referring to the same circuit. XNOR between QB QD is a serial input, right? So this थर्ड क्लॉक के बाद आपको 0110 मिलना बोले तो थर्ड क्लॉक के पहले अगर आपको सीरियल इनपुट 0 रहे तो ही आपको क्लॉक के बाद QA 0 मिलेगा, राइट? क्लॉक डालने के पहले अगर QA 1, QB 1, QC 0 रहे तो क्लॉक डालने के पहले, थर्ड क्लॉक डालने के पहले आपका QA, QB, QC are 110. Then only after clock signal QB, QC, QD will be 110, right? Now we are looking here, QB value is 1. It is to be XNOR with QD so that आपको serial input 0 होना चाहिए. So QB already 1 है, अगर आपका serial input 0 होना चाहे तो what you need, QD must be 0. अगर आपका QD 0 रहे तो QB XNOR with QD before third clock pulse we are having 0, that is coming to be serial input that will enter into QA after third clock pulse. Hence we are speaking before third clock pulse the content in the register is to be 1100. इसके दूसरा तरीका से बोल सकते it is the content in the register after second clock pulse. दूसरा तरीका से बताना बोले तो you need to speak it is the content in the register after second clock pulse, right? And same work you have to extend, यही वर्क अपन एक्सटेंड करना पड़ेगा. क्लॉक की सेकंड क्लॉक के पहले अगर आपका सीरियल इनपुट 1 रहे तो क्लॉक डालने के बाद QA 1 मिलेगा, एंड QA 1, QB 0, QC 0 रहे तो सेकंड क्लॉक डालने के बाद QB, QC, QD will be 100, right? Now we are coming to the same strategy. We are having here QB value which is already decided. The QB value which is already decided, it is 0, and we want serial input is to be 1. Then what's supposed to be QD is the question. So QD definitely you must read as 0. अगर सेकंड क्लॉक के पहले आपका रजिस्टर कंटेंट 1000 रहे तो सेकंड क्लॉक के बाद आपको मिलेगा 1100. In other way, it is the content of the register after first clock pulse. दूसरा तरीके से बोलना बोले तो it is the content of the register after first clock pulse, right? So after first clock pulse QA वैल्यू 1 होना बोले तो क्लॉक के पहले सीरियल इनपुट 1 होना पड़ेगा, राइट? एंड क्लॉक के बाद QB 0 होना, QC 0 होना, QD 0 होना, so that a clock के पहले QA, QB, QC supposed to be 0, 0, 0, right? Now QB value already decided as a 0 and expected serial input is 1, then what is the QD? QD is supposed to be 0. Hence, after 3 clock pulses, we want to have the content in the register is to be 0, 1, 1, 0. The initial content in the register is to be 0, 0, 0, 0 at QA, QB, QC, QD. So as a decimal value, if at all you are looking, it's a decimal 0. So the question is mentioned here as a decimal equivalent value. So answer to this question is 0. Answer to this question is 0. Okay. Let me discuss one last question. For the Boolean function f of w x y z, these are the minterms. Which of the following is static zero hazard free false prime implicant set? Static zero hazard free false prime implicant set. It is a question. Just 1 or 2 minutes time you take and try to speak which is coming to be the right answer. So to work on this question, of course, you need to use the K-map. So try on your own. You want to complete within 10 minutes. So a little fast. So static zero hazard false prime implicant set. So once you want static zero hazard false prime implicant set, we must try for product of some expression. For medical students it is no. In the case of the SOP, the smallest possible product term, in the case of the SOP, the smallest possible product term we are naming as prime implicant. Whereas in the case of the POS, the smallest possible sum term. These are there in your notes for medical students. The smallest possible sum term we are naming as false prime implicant. False prime implicant. In the case of POS, the smallest possible sum term. So POS में तो sum terms we will be reading from the K map. जो smallest possible sum term मिलेगा उसको false prime implicant बोलते. And here we want on this question, which is coming to be the static zero hazard false prime implicant set. The function is given with the minterms. Hence, we must identify first the maxterms of the function. If you identify the maxterms of the function, all the missing numbers, will be max terms, will be the max terms. So the missing numbers, if you look here, 1, 3, 5, 7, 8, 9, 14 and 15. So 1, 3, 5, 7, 8, 9, 14, 15. Right. So in the corresponding cells, we are writing the function output is 0, 1, 3, 5, 7, 8, 9, 14 and 15. Right. If you are looking to the minimal form, you are going to take this 4 cell subcube. So a 4 cell subcube का sum term आपको मिलेगा. This sum term W is with 0, so that capital letters I think I given. So W on complementary form X change हो रहा है, X नहीं मिलेगा, and Z is 1, so Z complement form, right? And coming to this, so this is a 2 cell subcube which is giving W complement or X or Y, right? And coming to this here, W complement or X complement, W complement, X complement or Y complement. So with a group of these three subcube sum terms, we are having coverage of all the max terms. But the thing is, here we have to identify the static zero hazard free prime implicant set. If you are looking here, when we are taking AND operation among these three sum terms, we are looking the subcube corresponding to this 0 and 7 and 15 is not covered in the minimal expression. So whenever this W value is changing 0 to 1 or 1 to 0, there is a possibility for the static zero hazard. So that the sum term corresponding to this to be used to make the circuit is to be hazard free. So sum term here, if you read well, it is coming as X complement or with Y complement or Z complement. Similarly, if we are not having coverage of the sum term corresponding to these two cells, then also we are having static zero hazard problem. So these two also adjacent cells, they are not covered in the minimal expression, so that the sum term corresponding to this supposed to be taken into account to make the circuit is to be hazard free circuit. So sum term corresponding to this, if you look well, it is X complement, not X complement, it is X or Y or Z complement. So that if you want to make the circuit is to be hazard free, the set supposed to be W or Z bar, W complement or X or Y, W complement or X complement or Y complement, and also these two sum terms to be used. So X bar or Y bar or Z bar, X or Y or Z bar. We are having the usage of all these sum terms in the minimal expression, then only the circuit is coming to be hazard free circuit. So if you look here, which is the matching? So W or Z bar, W complement or X complement Y complement, W complement or X or Y, X complement Y complement Z complement, X or Y Z bar. So that the matching answer we are having as option C. Hence, answer to this question is option C. Answer to this question is option C. Okay. So, with this, I want to stop this session. So, before closing the session, as what I discussed with the questions in the last year, GTQ 2021, the similar questions were present in the GATE 2021. Even that video is, YouTube video is still available on the YouTube channel. You can verify and you can compare the question paper. So with our experience, while looking at the previous few years question papers, I covered few of the questions even the last year, this time also. So based on my expectation, this time there is guarantee a question related with the XOR, XNOR operations. There will be a question related with the XOR and XNOR. And there will be a question related with the prime implicants and essential prime implicants. The prime implicant and essential prime implicant questions were not the questions recent times. Last time I think it was the question in the 2015. Even XR and XNOR last time, what I remember, 2019. And shift register question also recent times it is not the question. So these three topics I am looking as a little important. Mostly you will be having questions from this. Within the stipulated time of around 1.5 hour, 1 hour 45 minutes, what are the best thing is possible, I covered the questions, and with a single question I try to cover more than one different topics. So this video is available to you. So rewatch the video and try the questions on your own. Hopefully you can do. Try to learn the things with a smiley, gentle, smiley face. So with an easy mood, try to work. Definitely you can do easily all these questions. So what is the best thing is possible we delivered from our side, from MadeEasy team, as a MadeEasy team. Wish you good luck, all the best. Hope everybody will be having very good, prosperous, good future. Good luck, all the best for your GATE 2022 exam. Bye. I will look your comments. Sir, 5 minutes I will look your comments. And any good comment is there, I will read.